Detection is where AI security becomes observable. In this module, we'll turn prompts, outputs, API activity, logs, and user behavior into signals that reveal misuse, anomalies, insider threats, and incidents, while preserving the evidence needed for HIPAA, GDPR, and NIST-aligned audits. So far, you've built the foundation: mapping AI systems, understanding privacy obligations, analyzing risk, and applying governance, identification, and protection controls. Now we shift to detection, spotting anomalies, threat signals, and suspicious activity before they become incidents. Detect is where visibility becomes action. For AI systems, server and network logs are not enough. Teams also need telemetry from prompts, outputs, training data, model behavior, and user activity. When those signals are correlated, they can reveal misuse, policy violations, attacks, and unexpected behavior faster. They also provide evidence for compliance, escalation, and response decisions. Strong detection shortens dwell time before prompt attacks, data leakage, insider misuse, or model abuse can spread. Effective AI detection depends on connecting signals across the whole environment. Begin with identity, logins, sessions, role changes, and privileged actions. Then capture model activity, including prompts, responses, filtering decisions, and policy violations. Add application and API events, data access, vector searches, file retrievals, and admin actions. Finally, include infrastructure signals like deployments, configuration changes, exposed endpoints, and pipeline activity. Together, these feeds give the detection platform enough context to separate normal use from real risk. Think of the SIEM as the security memory for the AI environment. It ingests application logs, authentication events, prompts, API calls, and data access records, then correlates them with identity, cloud, endpoint, and network telemetry. The key is normalization: consistent user IDs, session IDs, model IDs, actions, and timestamps. With that structure, teams can connect a suspicious prompt, an unusual data query, and an admin change into one investigated incident. Good AI logs answer three questions: who did what data was touched, and what risk controls fired. Capture metadata such as user, role, session, endpoint, model version, timestamp, and risk score. Track retrievals, vector searches, exports, and policy filter decisions. Handle prompts and outputs carefully. Store content only when needed using redaction, hashing, sampling, and restricted access. Then protect the logs themselves with encryption, retention limits, access controls, and audit trails. Strong AI monitoring starts with use cases, not generic alarms. Decide what matters most: prompt injection, PHI exposure, data extraction, abnormal API activity, and privileged misuse. For each use case, define the signal, threshold, severity, and first response. Severity should reflect impact, confidence, data sensitivity, user role, and system criticality. Risk scoring helps combine weaker signals into one meaningful alert. The goal is tuning: fewer noisy false positives with strong visibility when behavior suggests real harm. Anomaly detection starts with a baseline: what normal looks like for users, models, outputs, and APIs. Once that baseline is clear, teams can watch for meaningful deviations. A sudden prompt surge, repeated jailbreak attempts, rising toxicity, lower confidence, or unusual geographic API traffic may all signal risk. Context matters. One odd event may be harmless, but patterns across behavior, performance, and access often reveal misuse, drift, or emerging attack activity. Baselining turns monitoring from guesswork into comparison. Start by choosing a signal, such as prompts, token volume, endpoint calls, data access, or error rates, segmented by role, department, application, geography, and time period. Then measure the normal range, accounting for launches, month-end activity, or scheduled campaigns. Deviations should trigger investigation, not automatic conclusions. Finally, validate alerts and retune regularly, because AI usage patterns change as adoption grows. Prompt abuse detection works best as a layered signal, not a single keyword filter. Start with obvious injection phrases, such as attempts to ignore instructions or reveal hidden prompts. Then look for repetition, escalation, and context. Who the user is, where the request comes from, and what data they are trying to reach. Classifiers, embeddings, keyword rules, and risk scores should work together, so suspicious prompts can be blocked, reviewed, or limited before they reach sensitive tools. Sensitive data exposure can happen before or after the model runs. Users may paste PHI, upload bulk records, or attach files that exceed the task's purpose. The model may also return personal details, overly specific summaries, or data pulled from restricted sources. Detection should combine DLP, entity recognition, classification labels, and access pattern monitoring. Repeated retrievals from patient, customer, or vector repositories deserve special attention because they may signal extraction, not normal use. Insider risk in AI is about context, not just identity. Imagine a privileged analyst who normally reviews aggregate results. One evening, they access unusual patient records, disable a safety filter, change a prompt template, and export generated outputs in bulk. Any one event might have an explanation. Together, they deserve investigation. Strong monitoring connects admin actions, access patterns, HR or role changes, approvals, and service account activity into a single risk picture. AI monitoring is broader than catching attacks. Once a model is deployed, teams need to watch for behavior that changes quietly over time. Inputs may drift, confidence may fall, latency may rise, or error rates may spike. Outputs also need safety monitoring for toxicity, restricted content, hallucinations, and unusual refusal patterns. The key is comparison. Before and after releases, tuning, prompt changes, or data updates. When behavior looks abnormal, escalate quickly to governance, security, product, and compliance teams. Detection only creates value when it drives a workflow. Dashboards should surface prompt risk, sensitive data exposure, API anomalies, and privileged activity. But every alert also needs context. Logs, prompt metadata, model version, user actions, and response history. Triage should have clear ownership across SOC, AI engineering, privacy, legal, and compliance. From there, integrate tickets, cases, incident response, and audit repositories so teams can prove what happened and act quickly. AI detection turns raw activity into actionable intelligence. Capture prompts, outputs, model events, retrieval activity, and traditional logs. Correlate them in the SIEM across identity, cloud, APIs, and administration. Then look for anomalies that signal abuse, drift, or data exposure. Those signals become the foundation for response and recovery.